The year is 1955. A newspaper clutched in her hand, Annie Easley walks through the gates of the Lewis Flight Propulsion Laboratory in Cleveland, Ohio. The headline that caught her eye was about twin sisters who worked at the facility as computers. The term was literal. In an era before digital machines, these were people, almost exclusively women, who performed the complex mathematical calculations that engineers needed to design the future of flight. Annie, with a sharp mind honed by 2 years of pharmacy studies at Xavier University, saw an opportunity. She wasn't just looking for a job, she was looking for a challenge. But as she entered the building, the air itself seemed to change. She was a black woman from Birmingham, Alabama, stepping into one of the most advanced and segregated scientific institutions in the world. The stares weren't just curious, they were a physical manifestation of a system that had already decided where she belonged. This was not just any workplace. This was the National Advisory Committee for Aeronautics, or NACA, the precursor to NASA. It was the intellectual engine of American aviation, a place where the sound barrier was being broken and the dreams of spaceflight were being sketched onto blueprints. Yet, on the ground, older, more stubborn barriers remained firmly in place. Segregated workplace. The bathrooms were segregated. The cafeteria was segregated. The very intellectual contributions of its employees were, in practice, segregated by race and gender. Annie was one of only a handful of African Americans among the 2,500 employees. Her hiring was an anomaly, a crack in a monolithic wall of exclusion. Her initial role was that of a human computer, a title that both described the work and subtly dehumanized the worker. The job was to be a living calculator, taking raw data from wind tunnel tests and engineering diagrams and, through sheer mental force and meticulous hand calculations, transforming it into usable results. It was grueling, repetitive, and intellectually demanding work, requiring a profound understanding of differential equations and advanced calculus. To understand the magnitude of her entry into this world, we have to understand the world she came from. Annie Jean Easley was born in 1933 in Birmingham, a city that would later become a focal point of the civil rights movement. Her mother's words were the bedrock of her identity. "You can be anything you want to be," she would say, "but you have to work at it." This was not a hollow platitude. It was a survival strategy. In the Jim Crow South, ambition for a black child was an act of defiance. Education was the only tool sharp enough to carve out a future. Annie excelled, becoming valedictorian of her high school class. But the system was designed to thwart such ambition at every turn. Years later, when she attempted to register to vote in the 1950s, she was confronted with the insidious tool of voter suppression, the literacy test. The registrar demanded she recite a specific article of the state constitution and calculate the number of jelly beans in a large jar. It was an impossible, arbitrary gate designed to disenfranchise. Annie, with her precise mathematical mind, calmly looked at the jar and gave a number. The stunned registrar, perhaps caught off guard by her confidence, passed her. But Annie didn't just walk away. Voter registration defiance. She began tutoring other African Americans, coaching them on how to navigate these unjust tests, turning a tool of oppression into an exercise in community empowerment. This was the spirit she brought to NACA. She wasn't just there to compute, she was there to contribute, to learn, and to grow. The launch of Sputnik 1 by the Soviet Union in 1957 sent a shockwave through the American political and scientific establishment. The space race had begun. In 1958, NACA was dissolved, and its assets, including the Lewis Research Center and Annie Easley, were absorbed into a new ambitious agency, the National Aeronautics and Space Administration, or NASA. The mission was no longer just about faster planes, it was about reaching the moon and the stars. This new urgency created opportunities. The demand for computation was exploding, and the era of the human computer was about to be rendered obsolete by the arrival of hulking, room-sized electronic machines. While many of her colleagues feared being replaced, Annie saw another door opening. She enrolled in mathematics courses at Cleveland State University, often as the only woman of color in the room, determined to master the new languages of the future, Fortran and SOAP, the programming languages that would teach these new electronic brains how to think. Her ambition was clear. She would not just be a computer, she would program them. But in an institution where her very presence was an exception, how could a black woman, initially hired for manual calculation, possibly be allowed to write the code that would power America's journey to the cosmos? From that segregated computing pool, a mind uniquely prepared for the digital revolution was about to emerge. The question of whether Annie Easley would be allowed to program the new machines was answered not by permission, but by her own sheer competence and the undeniable demands of the space race. As the first IBM mainframes were wheeled into the Lewis Research Center, their blinking lights and humming fans heralding a new age, Annie was on the front lines, teaching herself the logic and syntax that would become the language of space exploration. She wasn't just adapting, she was pioneering. She became one of the first and most proficient programmers at the center, a vital human bridge between the engineers with the theories and the machines that could test them. Her work was not on some peripheral project. She was assigned to the Centaur program, one of the most critical and technically challenging endeavors in NASA's portfolio. The Centaur was not just another rocket. It was America's first high-energy upper-stage booster. While the massive first-stage rockets like the Atlas could get a payload off the ground, the Centaur was the precision instrument designed to take it the rest of the way, into a stable Earth orbit, to the Moon, and to the outer planets. Its revolutionary power came from its fuel source, a combination of liquid hydrogen and liquid oxygen. This cryogenic propellant offered immense thrust, but it was also incredibly volatile and difficult to handle. The engineering challenges were immense, and the calculations required to make it work were beyond the scope of even the most brilliant human computing pool. This is where Annie Easley's work became indispensable. Centaur rocket schematics. She developed and implemented the computer code that was foundational to the Centaur's success. Her programs analyzed energy conversions, a critical factor for a rocket that had to perform flawlessly in the vacuum of space. Let's break down what that means. Her code served as the analytical backbone for the rocket's power systems. It could simulate different launch scenarios, calculating how the energy from the propellants would be converted into thrust under varying conditions. It helped determine the performance of the rocket's power systems over long-duration missions, a vital consideration for the interplanetary probes the Centaur would one day launch. One of her key contributions, documented in the 1971 NASA Technical Memorandum, Effect of Turbulent Mixing on Average Fuel Temperatures in a Nuclear Rocket Gas Core Cavity, which she co-authored, involved analyzing alternative power technologies, including the batteries that would power the equipment on these rockets, and concepts for nuclear-powered rocket engines. Her software was a diagnostic tool, a predictive model, and an optimization engine all in one. It allowed engineers to identify potential failures before they happened, to squeeze every ounce of performance out of the design, and to ensure the rocket could deliver on its ambitious promises. Without this foundational code, the Centaur program would have been flying blind. The impact of her work rippled through the entire space program. The Centaur, powered in part by the logic embedded in Annie's code, became NASA's go-to workhorse for its most important scientific missions. It launched the Surveyor landers to the Moon in the 1960s, paving the way for the Apollo astronauts. In the 1970s, it sent the Viking 1 and 2 orbiters and landers to Mars, which transmitted the first-ever images from the Martian surface. It propelled the Pioneer 10 and 11 probes, the first spacecraft to visit Jupiter and Saturn. And it launched the legendary Voyager 1 and 2 probes, which have traveled farther from Earth than any human-made object in history, carrying their golden records into interstellar space. Voyager's journey through space. Every stunning image from these missions, every data point beamed back across the solar system, owes a small but crucial debt to the code Annie Easley wrote in a lab in Cleveland. Her work wasn't just confined to space. She later applied her skills to analyzing energy systems for Earthbound applications, contributing to projects on solar and wind power, and even the development of early electric vehicle batteries. Her intellect was a utility, capable of powering rockets to other worlds and finding sustainable energy solutions for our own. Yet, as the public celebrated the launch of each new probe and the astronauts who became household names, the programmers who wrote the language of these triumphs remained in the shadows. With a contribution so fundamental and far-reaching, why is Annie Easley's name not etched alongside the missions she made possible? That question of recognition leads us from the clean rooms and computer labs of NASA to a single, stark photograph. It was a promotional image taken for a NASA open house meant to showcase the diverse and brilliant team at the Lewis Research Center. Annie Easley and her colleagues posed for the shot. But when the photos were later used for publicity, something was wrong. Her face and that of a colleague had been literally cut out of the image. The empty space where she should have been was a silent, brutal confirmation of the systemic erasure she had faced her entire career. Cut from the photo. This was not an accidental crop. It was a conscious decision to present a certain image of NASA to the world, an image that did not prominently feature a brilliant black woman. It was the physical manifestation of a career spent fighting for visibility. A symbolic act that mirrored the countless times her name might have been left off a citation or her contribution downplayed in a meeting. The injustice was no longer abstract. It was a jagged hole in a piece of paper. But Annie Easley was not defined by the prejudice she faced. She was defined by how she fought back. This incident and the daily current of discrimination she navigated fueled a second career that ran parallel to her scientific work, that of a fierce and dedicated advocate for social justice within NASA itself. She became an equal employment opportunity counselor. This was not a ceremonial role. She was an official investigator and advisor, a person to whom other employees could bring their complaints of discrimination based on race, gender, or disability without fear of retaliation. She would meticulously document their cases, interview supervisors, and challenge the institutional biases that prevented qualified people from being hired or promoted. She wasn't just solving equations for rockets anymore. She was trying to solve the complex human equation of systemic inequality. She used the same analytical mind that debugged Fortran code to deconstruct discriminatory practices. She understood that a system is only as good as its inputs, and for too long, the inputs at NASA and other institutions had been tainted by prejudice. Her advocacy extended far beyond the walls of her office. She became a tireless promoter of STEM careers for women and students of color. She would visit schools and college fairs, her presence alone a powerful statement that a career in science was possible for everyone. She understood that you cannot be what you cannot see. In interviews, she spoke candidly about the challenges, not to discourage but to empower. She talked about the importance of a strong work ethic, of not giving up, and of wearing the right attitude as a shield against negativity. When asked about the barriers for women, she was direct. It's not a woman's problem, it's a people problem. She saw the bigger picture, that the exclusion of talent for any reason was a loss for everyone. Her fight wasn't just for herself. It was for every young person who would come after her, ensuring the doors she had to force open would remain open for them. Inspiring the next generation. Annie Easley retired in 1989 after 34 years of service. Her legacy is a dual helix, intertwining profound technical achievement with relentless human advocacy. One strand is the invisible code running through the history of space exploration, the logic that helped power missions of discovery. The other is the visible change she helped create, fostering a more inclusive and equitable environment at one of the world's leading scientific agencies. Her story, once relegated to a cutout on a photo, is a powerful reminder that history is not a settled document. It is an ongoing investigation. Reclaiming her name and her contributions is not just about correcting an old injustice. It is about recognizing that genius has no race or gender, and that our greatest achievements as a species are built on the work of countless hidden figures. The question is no longer just about Annie Easley. It's about all the others, whose stories are still waiting in the archives, cut from the photograph of our collective history. We have to keep looking. Ever heard of the brilliant mind who helped integrate NASA's early computer systems, powering rockets into space, only to have her image symbolically cut from the historical narrative? This is the untold story of Annie Easley, a true pioneer whose contributions were as vital as they were overlooked. In this FullofMind deep dive, we uncover the extraordinary journey of Annie Easley, a Black woman who shattered barriers in the male-dominated world of rocket science and computer programming. From her groundbreaking work on the Centaur rocket program to her relentless advocacy for diversity, Annie's story is a powerful reminder of the hidden figures whose genius shaped our world. We explore her technical brilliance, her resilience in the face of prejudice, and the systemic erasure that kept her out of the spotlight. Join us as we celebrate Annie Easley's incredible legacy, shedding light on the critical role she played in space exploration and the ongoing fight for recognition. Her story challenges us to question who gets remembered and why, pushing us to seek out the full truth behind our greatest achievements. Don't let her story be erased again. Watch to discover the full impact of Annie Easley's genius and share this video to ensure her rightful place in history. What other hidden figures inspire you? Hashtag Annie Easley, hashtag NASA History, hashtag Hidden Figures, hashtag Rocket Scientist, hashtag Women in STEM, hashtag Black History, hashtag Unsung Heroes, hashtag Computer Science, Space Exploration, History Revealed.